Hello students, welcome to the class of digital electronics. Today we will discuss very important topic, the overflow. Although it's a very small topic, so we will discuss this small topic with an example. So before start the topic, the overflow, first let me just explain one more time the advantage of ones and twos complement. So this advantage of ones and twos complement, it is one of the advantage out of three. Already in the previous video, we already discussed the three advantage of two's complement. So now this is one of the advantage of two's complement out of three that we had discussed in the previous video. So the advantage is the extension of a number of bit is easy in both ones and twos complement form. Clear? So, how do we extend the number of bits? By simply copying the MSB. By simply copying the MSB bit, we can extend easily the number of bits. So, let's say, for example, in the ones complement, in the ones complement, how do we represent this plus 5? So, plus 5 is 0 1 0 0 1 0 1, correct? So, this 0 1 0 1, that is a representation of plus 5 in 4 bit. So let's say I want to represent this plus 5 again in the 5 bit. So uh, simply I have to copy the MSB bit. So if I copy the MSB bit further in the left hand side, okay. So 0 0 1 0 1 is again is a plus 5. Let's say I want to represent this same plus 5 in 6 bit. So 0 0 0 1 0 1, this is again plus 5. So actually I am retaining the same value. Okay, so this one is plus 5, this one is plus 5. If I extend the number of bit, this one is again plus 5, this one is again plus 5. So if I am retaining the same decimal value, then that is the concept of extension of a number of bit. Same here, how do we represent the minus 5? So negative number, as I already said in the previous video, in the ones complement, negative number is represented by taking the ones complement of the corresponding positive number. So positive number that we have 0 1 0 1. So by taking the ones complement of 0 1 0 1, that is 1010 is a minus 5. So negative number in ones complement is represented by taking the ones complement of the corresponding positive number. Clear? So this is a representation of minus 5 in 4 bit. So I want to represent the same minus 5 in 5 bit. So we have to simply copy the MSB. So 1 1 0 1 0, that is minus 5. And again, if I want to represent the same minus 5 in 6 bit, then 0 0 0 0 1 0, this is minus 5. So how do I know this number is minus 5? So let's just do take the ones complement of this number. Take the ones complement of this one number. Okay, so ones complement is 1 0 1 0 0 0. So now this number is plus 5. So if this number is plus 5, then this number is minus 5. Clear? So in two's complement also we can the same concept. If we apply the same concept, then we can easily extend the number of bit. So now see here again one more time. So plus 5, how do we represent the plus 5 in two's complement? So 0 1 0 1. So positive number in two's complement is represented as the same way as we have represented in the ones complement and in the sign magnitude form. So plus 5 is, that is MSB is reserved for the sign, and rest of the bits are responsible for the magnitude. So this is the plus 5. So same I want to represent this plus 5 in 5 bit. So 0 0 1 0 1, simply I copy the MSB bit. Simply again 6 bit, simply I have to copy the MSB bit. So this is the plus 5. Same here minus 5. So how do we represent the minus 5 in 2's complement form? So by taking the 2's complement of the corresponding positive number, that is the minus 5. So if I take the 2's complement of this positive number, then that is 1101, that is my minus 5. Okay, so the concept is, how do we represent the negative number in 2's complement? So we can represent the negative number in 2's complement by taking the 2's complement of the corresponding positive number. So if this is plus 5, then after taking the 2's complement of this plus 5, that will become my number minus 5. Now is it okay? So this 1011 is the 2's complement of 0101. Clear? So I want to represent this minus a 5 in 5 bit. So how do we represent? Simply copy the MSB. And next, if I want to represent this minus a 5 again in 6 bit, so simply I have to copy the MSB. So 111011 is a minus a 5. So how do I know this 111011 is a minus a 5? So simply I have to take the 2's complement because this number is negative. So one important point is there in one's complement and two's complement. If suppose statement is given like this, the number is given in the two's complement form, find the decimal value. So if the number is given in the two's complement form or in the one's complement form, simply we have to check the MSB. Okay, if MSB is 1, then the number is negative. If MSB is 0, then number is positive. So if number is positive, no need to take the 1's complement to 2 and 2's complement further. But if number is negative, for say if MSB is 1, then number is negative. In that particular case, we have to take the 2's complement. If suppose statement is given in the like this, the number is given in the 2's complement form. So same number, suppose this number is in the 2's complement form, find out the decimal value. So if uh, what we have to check, the MSB. If MSB is 1, then number is negative. So we have to take the 2's complement. So 2's complement of this number is 101000. So that is the 2's complement, and this number we know already, this number is plus 5. So if this number is plus 5, then this number is minus 5. Okay, so simply we have to check only the MSB. If MSB is 1, then it is clearly understood that the number is negative. Okay, and if number is negative, then we have to take the complement to get the decimal value. Okay, so now the important point is, now the question arises here, what is the need, of the extension of a number of bit? Okay, what is the application of a extension of a number of bit? So let's take an example. So I want to add plus 5 and plus 4. Okay, these two number I want to add, okay, using 2's complement. So now the important point that we will see after addition of plus 5 and plus 4. Now you see plus 5. So how do we represent the plus 5? 0101. So this is my plus and 5. So how this number is plus and 5? This number is reserved only for the sign, and these three number is reserved for the magnitude. Okay. Again plus 4. How do we represent the plus 4? This is positive and this one is the magnitude. So after addition of these two, plus 5 and plus 4, 1 0 is 1, 0 0 is 0, 1 1 0 with carry 1, and finally that is 1 without carry. Okay, so result is this result is minus 1. This result is minus 1. Correct? So the point is, if we are adding the same sign bit number, if we are adding the two same sign bit number, okay, then result also with the same sign bit number. Okay, so the result also should be the positive, but here the result is negative. That is practically not possible. So the point is, that this condition that we can call as a overflow. This we can call this as a overflow condition. Okay, so now what is the cause of this overflow? Now you see the range in the 2's complement is minus 2 raised to power n minus 7 to plus 2 raised to power n minus 7 minus 7. This already that we had already discussed in the previous video. Okay, so if suppose n is equal to 4, then what is the range to represent the number, decimal number, okay, in 4 bit? So minus 8 to plus 7, we can represent up to minus 8 to plus 7, but answer here, that is a plus 9. So that is a overflow condition, means we cannot represent the plus 9 in 4 bit. It's very simple. Again I am repeating, we cannot represent the plus 9 in 4 bit. Clear? So the point is, here we cannot represent the plus 9 in 4 bit. So what is the solution? Solution is extension of a number of bit. Extension of a number of bit. So here I have written here, during addition, if two same sign number is added, the result may be opposite sign. That will indicate the overflow condition. Now is it okay? So plus 5, earlier that we have represented plus 5 by 0 1 0 1, okay, and plus 4 is 0 1 0 0. So now the solution is, solution of overflow is just simply we have to copy the MSB bit. So now in the 5 bit, 0 0 1 0 1, in 5 bit 0 0 1 0 0. So now if I add this plus 5 and plus 4, 1 0 1 0 0 0 1 1 0 with carry 1, and finally that is 1, and at the last MSB is 0. So this number is plus 9. This number is plus 9. Okay, so that is the use of the extension of a number of bit. Clear? So if two same sign number, what is the meaning of same sign number? Here now plus में 5, what is the plus of 5? That is 0 1 0 1. Okay, plus 4 is 0 1 0 0. So if two same sign bit number, if we are adding, so same sign bit means that is this is plus 0. Sorry, the MSB is 0. Here MSB is 0. So if we are adding the same sign bit number, the result may be the same sign or maybe the opposite sign. So if result is opposite sign, okay, if result, this is the result, if result is opposite sign, then that is the condition of overflow. I am explaining in detail one more time. Now you see this one. This is the condition of the overflow. So here, what is the x, y and z? X and y are the sign bit of the two number. X and y are the sign bit of two number that I want to add. Okay, and z is the sign bit, z is the sign bit of the result after addition of x and y. Okay, is a sign bit of the result that we are getting after the addition of x and y. So if x and y have the same sign bit number x and y, but the result is in the opposite in nature, z, opposite in nature means x bar, y bar, z, or if suppose same sign bit x and y, but z is opposite in nature, then that is the condition of the overflow. If any one of the term, if here two terms is there, this one and this one, so if any one of the term is satisfied, then that is the condition of the overflow. Clear? So again I am repeating, x and y, that is a sign bit of the two number that we want to add. Okay, and z is the result after the addition of x and y. So if z is the opposite sign, now you see here, this is bar, and z, that is without bar. Okay, see now x without bar, y without bar, and z, that is a bar is there. So if suppose this condition is there, if suppose this condition is um, satisfied after the addition, then that is a condition of the overflow. Clear? So now one more example. Okay, so now you see here, x is equal to this 0 1 1 0, 0 1 1 1, 0, and y is 11001. These are the two sign bit number. Okay, 5 bit, 5 bit 2's complement form. These two are 5 bit in 2's complement format. Okay, and the sum of x and y represented in 2's complement form is, okay, format is. So now we have to check the options. So all options are in 6 bit. All options are in 6 bit format. Okay, but the data that we have given in the 5 bit format. So what we have to do, first we have to convert this x in 6 bit. Okay, so how do we change, or how do we extend the number of bit? So simply copy the MSB. Simply copy the MSB. So y, again simply copy the MSB, that is in 6 bit. Okay, so first it's very simple. First point, that is very simple. Just you see in the option, if suppose number of all options are given in the 5 bit, then no need to add the, or no need to extend the bit. So now you see here, x is 0 MSB and y is 1. So there is no chance of occurring of overflow condition. Clear? Because the occurrence of the overflow condition happen when x and y have the same sign. Okay, but here x and y have the different sign. So here the chance of occurring of overflow is not there, but it's another one more concept, that is the application of the extension of a number of bit. So if suppose in the question itself, if suppose it is given like that, y, x and y represented in 2's complement form format in 6 bit, in 6 bit. Okay, then the same we have to extend the number of bit. If suppose it is not asking like in 6 bit, and suppose in all options that is 6 bit format is there, then again we have to extend the number of bit. So the after addition of this x and y in 6 bit, so let's see, 0 1 1 1 0 1 1 0 1 1 1 0 with carry 1, 110 with carry 1, 110 with carry 1. So carry, that is discard. You discard the carry. So finally the answer is triple zero one 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 triple one. So the correct answer is C. So that is another kind of use of extension of a number of bit. Clear? So in the next video, we will solve the few examples of complement of a number system. Okay, clear? And in the next video, that we will discuss the very important topic, floating point representation. Clear? So that's all from my side. Thank you.